Hello everyone. Today I'm here with class 12th chapter probability lecture number 5 homework solution. So here we start with our homework solution. I'll be giving you solution of some of the questions of homework. As you can see, here is question number 2 of miscellaneous exercise, in which they are saying a couple has two children. So let us first write down this sample space. If a couple has two children, both can be girls, both can be boys. One can be girl, another can be boy. The elder is a girl, the younger is a boy. Similarly, the elder can be a boy and the younger can be a girl. In the first part, they are asking us to find out that find the probability that both the children are males. We have to find the probability that both the children are male. So E is an event that both children are males. Okay. What if it is known, then this is the given condition that it is known that at least one of them is a male. So F will be an event which shows at least one of them is a male, right? Here in the first one both males, in the second one at least one of the children, one is male. Okay, now you see what we have to calculate. We have to calculate probability of what is the given condition, that at least one is a male. So that I have written in the given condition. And what we have to find out, that both of them are males. So this will be given as we have done the formula already. This is a question of conditional probability E intersection F divided by number of elements in F. Let us find out number of elements in E, or both the children are males, so only this is the event which is favorable to this. So B, both are boys. Now at least one is male, at least one is male. So which are the favorable one? We will have girl boy, girl, and boy. At least means we can have more than one also. So what is the common number of elements in both of them? As you can see, this is common in both, so only one element, number of elements common to them is 1. In E intersection F, only we have BB. Now applying the formula and placing the value, number of elements in F is 3. So for the first part, the answer will be 1 by 3, which is probability of both the children being male, given that at least one of the children is a male. Okay, similarly, you are going to do the second part. I think that can be done easily. Let us move to the next question now. Here is question number 3. Okay, so in this question, they have given us that 5% of men and 0.25% of women have gray hair. So you see, in the same statement, there are two information: being a man and having gray hair, being a woman and having gray hair, right? Two things in one statement. Then they are saying a gray haired person. A gray haired person is selected at random. What is the probability this person being male? That means we already know what is selected, that the person has gray hair. The person has gray hair. What we have to find out, that he is a male. So we'll consider one event and that of male, and E2 that he uh, that the person selected is a female. And they are saying assume that there are equal number of males and females. So I can write probability of even and E2, that means being male and female is half, because they are equally probable, right? Equal number of males and females we have, so any of the person can be selected. Now what they're asking us to find out, that a gray person is selected. So we already know this information, that the person selected has gray hair. We have to find out that the person is a male. So for male the event is even, so we have to find out even by A. Can we calculate P of A by even? A given even means that the person selected is a male and has gray hairs. That is, the probability is 5%, which is 5 upon 100. Similarly, we have probability of A given E2, that means we know the person selected is a female and has gray hair. The probability given for that is 0.25%, 0.25 upon 100. Correct. Now we can use this in the formula. The favorable event to us is even, and P of A by even divided by the total probability taking summation of both the cases. A given even plus probability of E2 into P of A given E2. So we have all the four values to be placed in the formula. We can put them and can calculate the value for probability of the person selected who is having gray hair and is a male. Correct? Let us move to the next question now. So the next question is here. Very easy. We have done once this in class 11th as well. It says a leap year. A leap year means how many days? 366 days, right? Is selected at random. What is the chance that it will contain 53 Tuesdays? So when I divide 366 by 7, I can calculate actually number of weeks. So let us just do that. So I'm dividing it with 7. 7 5s are 35. You subtract, you get 1. Then you get 6 copied here. So 7 2s are 14. We subtract, we get 2. So we have actually 52 weeks and 2 days extra. Right? Now in 52 weeks, we'll have 52 Tuesdays. Right? So the probability is 1 for this. That's a sure event. Now we have to focus on this. These are the 2 days. So for the 53rd Tuesday, out of these 2 days, we can have the possibility. These 2 days can be Sunday and Monday, Monday and Tuesday, Tuesday and Wednesday, Wednesday and Thursday, Thursday and Friday, Friday and Saturday, Saturday and Sunday. So these are the possibilities because 2 days will have the consecutive ones, right? Let it be Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, and all. So out of this, the probability of coming up of Tuesday I see is 1 and 2. Two events are favorable, two outcomes are favorable out of the 7. 1 2 3 4 5 6 7. We have total 7. So the probability of 53 Tuesdays will be 2 by 7. Quite easy. Everybody can attempt it, right? Let us go to the next question now. Here comes your next question. Question number 11. In question number 11, it says a man wins a rupee for a 6 and loses. See, wins when it is a 6, loses when any other number, when a fair die is thrown. So when we throw a die, if he is getting 6, he wins. If he gets 1, 2, 3, 4, and 5, he loses. Okay, now they are saying the man decided to throw the dice 3 times. So he is performing the experiment 3 times, but to quit as and when he gets a 6. So he will quit the game as soon as he gets 6. Find the expected value of the amount he wins or loses. Expected means mean. Let us see how to calculate that. So I'll just draw one table, okay, showing all the 4 outcomes to us. Okay, now what are we going to write? We'll write the probability here. Okay, let me write that as A. And we are going to write the event. So let us just form the table and write all the outcomes. So see, I see there will be 4 cases made. How? The first case will be when he gets in the first throw, he can get 6. He can get 6 in the second throw. He can get in the third throw, or he might not get in anyone. He might not get in any one of the throw. So what will be the probabilities of event even E2, E3, and E4? So let us just write that. E2, E3, and E4. Okay, even is the event that in the first throw if he is getting, What? 6. So the probability of winning is this. What will be the amount that he would be receiving? So I'm writing the amount. So make one more column for it, one more row I am adding, drawing out the columns. Just to see. Probability of even we are supposing that in the first row only he will get a 6. That means he wins. The amount that he gets is rupees plus 1. Second event, that means he did not get 6 in the first. So what is the probability that he loses? It is 5 out of 6, right? So 5 by 6, that means he lost in the first chance. Then if he lost, he will go for the second time. So it will be 5 by 6 into 1 by 6. Right, and the money that he will get it 5 by 6 for losing minus 1, for winning plus 1. And he quits as and when he gets 6. So if he got 6 in the first row, he'll stop there. So I've taken that case. He might get it in second, he might get this in third now. So see, in the first two he's going to lose, and in the third he's getting 6. So it is 25 upon 216. You can calculate from here. The amount that he get is minus 1 plus 1. Okay, so here the amount is 0. Here the amount is minus 1. Now in the next, the fourth event, where we are saying that probability of E4 means he did not get 6 in any of the throw. So the probabilities will be losing in first, losing in second, losing in third. So that becomes 125. 125. The probability will become 125 upon 216. So just placing that 125, just a second. So you get 125 upon 216. So here writing 125 upon 216. Okay, now what is the money that he will be getting? Minus 1, minus 1, minus 1, because he loses every time. So minus 3 is the money that he is receiving. Okay, this is clear now. How do we find mean? We have to multiply this probability with the amount. Okay, so for the first one, how much is he getting? So I'm writing that the probability for the first was 1 by 6 and the amount is plus 1. For the second one, the probability, as I can show you. For the second one, the probability is 5 by 36. Clear? So 5 by 36 is the probability, and we are going to multiply it with, as 5 by 6 came, how? In the first he lost, in the second, so it is 0. Second he got the winning amount. In the third one, the probability as follows, as you can see from here, 25 upon 216, and the amount is minus 1. So I'm writing that 25 upon 216 and the amount is minus 1. And the last one, the probability is 125 upon 216 and the amount is minus 3. So what you have to do is you have to multiply them like this. 1 by 6, it will be 0. It will be minus 25 upon 216. The next one will be minus 375 upon 216. So you just have to add 1 by 6 plus minus 25 by 216 minus of 125 by 216. When you solve it, take the LCM. You get the answer after cancellation as minus of 91 by 54. Okay, in NCERT, old NCERTs, mostly the answer is given as 11 by 216, which is wrong. In the NCERT's updated version, this is the correct answer which is given. In old NCERT, this case they have not taken. Okay, and it was an error, then it was corrected, and now it is there. So the correct answer is minus 91 by 54. Let us now move to the next question. Question number 13. So in question number 13, they are saying if each element of a second order determinant, second order as I told you already, it is 2 cross 2. That means it will have 4 elements. A11, A12, a 2 cross 2 matrix this is, A21, A22. In determinant form, we write it like this. For each of the four options, they are saying we have, for all the four elements, we have either 1 or 0. So here 1 can come, 0 can come. At all the four places, these are the options that we have, either 1 or 0, 1 or 0, right? They are asking what is the probability that the value of the determinant is positive. We have to find out that the determinant value is positive. So as you can see, there are four elements, and for each element we have two options, either 1 or 0. So for each element two options, 2 into 2 into 2 into 2, 2 to the power 4, that is 16. So total number of determinants that will be formed using 1 and 0 are 16. Let us see how many of them are favorable to us. We get the positive answer only when here these two values are fixed as 1 and 1. Because if I fix 0 here, then I'll get a negative answer. Here it can be 0 0. Fixing here 1, it can be 0 1. Also, fixing 1 and 1, it can be 1 and it can be 0, like this. So these are the changes made here, and 1 and 1 I have fixed so that I get 1 minus 0. Correct. Now how many are favorable to us? 3, and total is 16. So the probability will be 3 by 16. As you can see, these are the three favorable cases to us. These three. So the total probability is 3 by 16. I hope this is clear. Now I'll discuss the last question of today's lecture, which is question number 16. In this question, as you can easily identify, the question belongs to which theorem? Here it says bag 1 is there in which 3 red and 4 black balls are there. In the second bag, it says 4 red and 5 black balls are there. As you can see, I have written the information from here itself. Now they are saying you are transferring one ball from bag 1 to another. When you transfer one ball, it can be red or it can be black. There are two events that can happen at this time. Now what are they saying? Then a ball is drawn from bag 2. From this bag you are taking out a ball, and the ball drawn is found to be red in color. What is the common thing? Whether you transfer a red ball, whether you transfer a black ball from bag 1 to bag 2, the common event that is happening is the another ball that you are taking out from bag 2 is of red color. So I'll consider A event as that the ball from the second bag is red. Okay. Even will be the event that a red ball was transferred. Okay. Red ball was transferred from first to second bag. E2 be the event that red ball is, we have taken red ball, we will take black ball. That black is transferred from first to second. Fine. Now if black ball is transferred, what we have to actually calculate? We know that the ball is of red color. What do we have to find? That the ball transferred was black. So for black, which is the event? E2. So we have to calculate E2 given A. Okay. Can you calculate P of A by even? A by even means transfer ball is red, and then the second ball that you are taking from the second bag is of red color. So red color probability is how many? If you are transferring a red ball, the red ball becomes 5 in number. So 5 upon total balls will be 10. Similarly, probability of A given E2 you can calculate. Just to see, event E2 means black ball is transferred. If you transfer black ball, there will be 6 black balls, and but we are picking out red balls only. So red ball is 4 divided by total number of balls, which is 10. Now for this, you know the favorable outcome, even and A, right? So you can just place the values in the formula and can get the answer for this. This is the only thing to be done in the question. I hope this is also clear to everyone. So in the next lecture, we are going to learn about random variable and probability distribution. So that's all for this homework part. Thank you so much.